The purpose of this lab is to answer the question, how can we determine the coefficient of friction of an accelerating system? The object we're going to study is the red dynamics cart. For your hypothesis, I'd like you to make an educated guess. What is the coefficient of friction for the dynamics cart and the table? In other words, what percentage of the cart's weight would you have to push with to keep it going? Is this going to be a large or a small number? Does the cart have a lot of friction or a little bit of friction? That should guide you as you think about writing a reasonable hypothesis. Here's the materials. You will need one red cart, one whiteboard, one piece of string, one set of masses, 220 gram and 110 gram, a pulley clamp, which is a pulley attached to a clamp, one roll of masking tape, one motion detector, a CBL adapter, a calculator, a CBL, calculator-based laboratory, and you'll need access to a triple beam balance with a 1,000 gram counterbalance so that you can mass things that have more than 1 kilogram of mass. This person is trying to plug the motion detector into the wrong port. They will now put it into the correct port, which is the sonic port on the side. That's the sonic port. We get the big thumbs up. This group has correctly plugged in their CBL to their calculator. They've pushed in the connecting cables all the way. This group has correctly set up the lab with the pulley clamp and the string and the mass. They've put 40 grams hanging over the side. This group needed an adapter because there's no batteries in the CBL and they've plugged it into the wall. You may want to push the table against the wall. That group is correctly measuring the motion detector plus the red cart. Here's a good trial. The cord is out of the way. The cart accelerates. We get the big thumbs up. And we do our velocity time graph and we notice that we have a nice constant slope we can now trace to get 2 points. Here's a big mistake. Don't put the motion detector don't tie a knot in the string, and don't let the mass hit the ground too soon. This group did that same mistake. If you follow all these steps, if you reduce your errors, you will end up with an excellent graph with a nice constant slope.